Hello and welcome to the second in our series of live stream events hosted by Cyient. This is part of our CXOCyience Designing Tomorrow Together series. My name is Des Blanchfield and I have the honor of being your host and moderator for today's event, focused on enterprise business transformation through next generation networks. Next generation networks, in particular, converged private networks across enterprises, often designed to leverage 5G, are opening up possibilities on many fronts, resulting in the rise of innovative business models as new use cases emerge for consumer and enterprise needs. In particular, we're seeing ever increasing opportunities for organizations to gain significant enterprise business transformation through next generation networks and leveraging those technologies. And by adopting new operating models and use cases, the technologies which make next generation networks and converged networks possible. In fact, the range of different architecture that enterprises can now consider when implementing private networks continue to open up powerful new opportunities for enterprise business transformation. Many previously considered the stuff of telcos and carriers are now available to enterprise customers across the spectrum, pun intended. The focus is now not only to build it right the first time, but also build it intelligently so that operation and management becomes effective and efficient. To achieve such transformative outcomes, it has become ever more critical that organizations find the best possible partner of choice to support them, keeping in mind that it is not usually core business for most organizations to implement, operate, or manage next generation networks. Now, I'd like to just invite folk as we kick off the hour to join this conversation through both the question and answer features of the platform here on GoToWebinar, as well as social media on Twitter with the hashtag DesigningAConnectedTomorrow. Please ensure you're following Cyient on Twitter at Cyient and search for the Designing a Connected Tomorrow hashtag now and click on latest and pose your questions for us there. The team will bring them into us through the conversation. Now, today I'm joined by two amazing experts in business technology and telecommunications. Let me briefly introduce today's panel to you. Firstly, we're joined by Ray Achemedei. Ray is the General Manager of Technology and Digital Transformation from Horizon Power. Ray, thanks for making time to join us today.
Thanks, Des. Pleasure to be here.
We're also joined by Aashu Virmani. Aashu is the Vice President and Client Partner for Communications from Cyient. Aashu, great to see you. Thanks for making this event possible and really appreciate you making time to join us today.
Lovely to be here, Des.
So folks, we have a fantastic hour of power ahead for you. So let me just briefly outline what today's agenda is, and then we're going to kick off with a market update from Aashu, looking at all the latest news and trends, and particularly what's coming out of Cyient. So we're then going to also have a live panel discussion following that market update from Aashu with our expert panelists just introduced you to, sharing their unique insights and perspectives on the topic of designing intelligent infrastructure, and particularly from the network point of view. Today's panel conversation will include topics such as enterprise business transformation through networks, next generation networks. For example, what 5G is all about and what it means for enterprise transformation, what enterprises can do in the case of new use cases and which use cases are enhanced and made possible by 5G. Some of the different architectures that enterprises consider and can consider rather when implementing private networks. And we're going to also look at some of the traditional mechanisms of feasibility surveys and physical walkabouts and how the new networks can empower the likes of LiDAR-based surveys and virtual network walkabouts. So let me bring, before we kick off the panel conversation, let me bring Aashu in here for a market update. I'd like to invite Aashu Virmani, again, Vice President, and of Client Partner and Communications at Cyient. Aashu's going to give us a brief mini keynote style market update around enterprise business transformation and next generation networks, as well as some of the latest news and insights from Cyient. Aashu, I wonder if I could hand over to you here for your market update, please.
Certainly, Des, and thank you, Des, and thank you, Ray. Pleasure to be here alongside you guys. Since today's discussion is mostly about enterprises, let me just focus on that segment. I know we have done topics like this covering the CSP market earlier with you. I think there is a confluence of trends that is creating a lot of transformation, almost like a perfect storm. Let me narrate maybe 5 key trends that I see. The first of these is around network function virtualizations, what we call NFV. What it allows us to do is to almost shrink, a mini cellular network and get it deployed and launched in a much simpler and cost-effective manner. You see, previously the design point was designing for CSP networks, and the idea was to scale up and how big you can scale it. The idea with enterprise networks is to simplify the installation, the deployment, and shrink it down to a size which is cost-effective for even mid-sized enterprises. So I think that is happening. The second trend we are seeing in our conversations with customers is a convergence of IT and OT networks. You see, Process 3.0 or Industry 3.0 was about process sensing. Industry 4.0, as I hear, is more about process control. And enterprises are increasingly realizing that, to the extent that they are going to end up managing an OT network as well as an IT network, and then these things are merging, we'll see a lot more of their investment in private networks that allow that to happen. The third point I would say is the quote unquote arrival, and I use the word arrival in double quotes, arrival of 5G. We will certainly talk more about it today, but the question is, when do you call a technology to have arrived? In our opinion, right now there's about 140 plus, according to the GSM Association, 140 plus 5G deployments around the globe. So at least from a consumer perspective or a macro network perspective, you could say, yes, the technology has arrived. And then we'll talk more about where we're seeing this in the enterprise market. It is a pretty vibrant and healthy ecosystem. There are certain unique characteristics within 5G that allow an enterprise business transformation to happen. Point number 4, and this has to do with more enterprise networks, is the spectrum availability. So governments and regulators across the world in different markets are allocating chunks of spectrum, particularly for enterprise use. The methods may be different, but the end result is the same. So for example, in the US, there is a chunk of mid-band spectrum called CBRS, the Citizens Broadband Radio Spectrum, that has been allocated, and it is a shared spectrum between public safety as well as enterprises. Germany has taken a different approach where they have allocated a chunk strictly for enterprise use. UK is taking a slightly different approach, for example, where they have localized spectrum based on geography. But the idea is that regulators are listening to enterprises. Enterprises are petitioning that there be spectrum made available for them to operate their mini cellular network, so to speak. So that is happening. And the fifth is, I would say, an early evidence, right? So we have seen studies from Bain, Deloitte, etc. And according to a study from Bain, the annual market, starting this year, 2021, is about $1.5 billion, and this is divided across various industry verticals, and it's growing at somewhere between 12 and 20% CAGR. So let's say, and that depends on the industry we're talking about, but it's about on an average of 15% CAGR. And with Cyient's own mini cosmos, where we have 150 large accounts across 10 verticals, you have rail, mining, automotive, transportation, etc. We just in the last 6 months, we have seen somewhere between 16 and 18 of those customers publicly announce their intent, or they have said that they have acquired a spectrum and they're going to build out their own private network. So to me, that is great early evidence that this thing is beyond just a fad. This is beyond just an exercise in technology, and the use cases are here to stay. Let me, and the 5 factors that I laid out is just sort of the tip of the arrow. There are public-private partnerships happening. There are partnerships among different SI vendors and product vendors happening. There is enough wood behind the arrow, so to speak. Let me put it to you, Des. I know you talked to a whole bunch of CXOs. Are you seeing something similar in your part of the world?
Very much so, and in fact, thank you, I'm honored. Yeah, so globally, what I'm seeing is that enterprises of all shapes and sizes are developing strategies already. And in fact, many of them have got well underway with their roadmaps and plans to design, test, trial, and even roll out private converged enterprise-grade networks, predominantly with the aim, as you mentioned before, to leverage 5G and its core capabilities. One of the things that really struck me there when you were talking about this is that, for many of these organizations, this is not their core strength. It's not their core business. Transport, logistics, aviation, financial services industry, healthcare, government, they're not in the business of building and maintaining, operating, and managing networks. They're in those relevant industries. So one of the biggest challenges these enterprises and organizations are facing currently, from what we're seeing in the conversations we're having, is the skills and experience gap within their own ranks. Their HR departments are often struggling to source in-house experts with experience and knowledge of modern networks And this invariably sees them, in our view, looking to the market for a partner of choice, a preferred partner to bring those capabilities to their organizations. More often than not, the challenge to implement and manage converged networks and to leverage 5G, as I said, are not their core business, but if they don't make it part of their core business and their overall strategy, their competitors may well do. And that creates a few challenges for them there. So naturally, as I mentioned, they now need the right technology and telecoms partner to work with them and to deliver those successful outcomes in a timely fashion. And based on some of the things you were talking about there before, I see this as the perfect opportunity for the likes of Cyient to meet that call for such needs and to meet that call today.
Yeah, so thank you for adding that color, Des. In order to design, build, and manage these networks, we think there is at least 3 kinds of skill sets that are required. First, of course, is the comms expertise, right? So, and I belong to the comms and utilities BU. So Cyient has that in spades. We have been, serving our 35 large CSP accounts for over 2 decades now, helping them roll out both, wireline and 4G, 5G networks. The second, which is very unique to Cyient, is that we are also structured around 10 vertical BUs. So we have domain knowledge. So the domain knowledge part is really critical, because when you're designing a network for a mining company versus a utility versus manufacturing or industrial network, these have different characteristics. So we pair the comms expertise with the domain expertise. And the third part is that we need, and this is my personal view, we need an element of vendor neutrality and a customer first approach. If I was building gear, I mean, we have no dog in the fight, to use that phrase. If I was a product vendor, I would be almost compelled to push my product first. Whereas Cyient can think about the customer, we can think in a very neutral fashion on what exactly is the use case. And then layer in not just the comms and the domain expertise, but we have 1,000+ person digital services team that can layer in that exact use case and provide a full stack operational network. On top of that, we can also do various innovative financial models, whether it's a build, operate, and transfer. And to your point, many of these customers feel not comfortable running a comms network of their own. So we can run the entire thing as a network as a service offering. And by the way, to give you the point about this being $1.5 billion market growing at, I think, as it happens with most new technologies and most new trends, the market severely underestimates what the market size is. That's the top-down estimates that we hear from analysts. If you just think about it from a bottoms-up perspective, there are 54,000 mines around the world. There are more than 47,000 power generation plants. There are 10,000 military bases, 3.3 million warehouses, and more than 11 million industrial and manufacturing sites around the world. If each of these is a candidate for a private network, our sense is that this market is, if not 2, at least 3 orders of magnitude bigger than what the industry is estimating right now. So I'll leave it at that, for you and the audience, and let's move ahead. Thank you.
Indeed, thank you, Aashu. I think there is no question whatsoever that this is an exciting new emerging space. There are opportunities across all the spectrums, if you'll pardon the pun. One thing that really struck me there is that Cyient is very uniquely placed to answer that call. So folks, I'd like us to pivot now to our panel conversation. So I have introduced both of our guests, but let me just bring them back in here now and ask them to give us just a little brief introduction by themselves of their role and what it entails, and some information about their organization. And then we'll dive into a couple of key topics that we want to discuss in today's panel. So Ray, I wonder if I could start with you. Ray Achemedei, the General Manager and of Technology and Digital Transformation from Horizon Power. I wonder, Ray, if we could start with you to give us a brief introduction to yourself and your role at Horizon Power.
Sure. Thanks again, Des, and hello, everyone. It's a real pleasure to be with all of you here today. So let me start by explaining a little bit about Horizon Power. For those who aren't familiar with us, we're a commercially focused but state government-owned enterprise power company. We provide electricity into regional Western Australia. We're vertically integrated. We're the only power utility left in Australia that's fully vertically integrated, and we're responsible for generating, distributing, and retailing electricity to more than 47,000 customer connections across our service area. The interesting aspect of this, however, is that our service area has a geographic footprint of 2.3 million square kilometres, which means we service the biggest area in the world with the least number of customers. So some very interesting and unique challenges for us in that particular context. Within our regional areas, we actually maintain 34 microgrids. So these are isolated power systems. And for us, in our world, a microgrid is effectively like a regional town, okay? And in addition to that, we also have 4 fairly large interconnected systems in addition. So it's important to note, because this is all helpful context, that these systems are actually exposed to very, very extreme, intense heat and cyclonic conditions in the north and ravaging storms in the south. So, you know, as it's summer here in the southern hemisphere, some of our workforce are out there operating and maintaining assets in temperatures in excess of 50 degrees Celsius. And literally as we speak, we have 2 tropical cyclones that are converging on our coastline with huge potential to disrupt our operations and services to our customers. So a little bit about our operating environment. We do all of this. We employ about 500 people on our payroll who mainly live in the main regional towns to support and maintain these systems. And the way we generate electricity varies between our systems. So most of the mainstream towns are serviced by gas, so fossil fuels, and smaller communities by diesel. There's an enormous drive on at the moment, increasingly more so over the last few years, to introduce renewable forms of energy into our energy supply, renewable energy into our energy supply. So essentially my role, I've only been with the organisation for just over 12 months now, but I was brought on board to help transform our business into what we call a utility of the future, which means a couple of things. One, ensuring our future business models are aligned with heightened consumer expectations around access to green energy, and also participating as prosumers in the supply of energy. So harnessing rooftop solar that our customers have and safely, reliably and efficiently introducing that into the supply system, electricity supply system. The other big rock, if you like, is transforming our electricity supply networks so that they use digital technologies to detect and react to local changes in usage, as well as condition of the assets and the environment that the assets live within. So Horizon's my first foray into the electricity sector. Before this, I spent 35 years predominantly in the mining industry. And in fact, my last role, my team led the deployment of 2 private 4G systems. The first was to support the real-time dispatch of haul trucks and drills within our mining operation. And the second was to support the operation of control systems that were running on transshippers, loading ore carriers. And typically these transshippers were somewhere up to 8 nautical miles offshore. And because there's a lot of drive on within mining in terms of remote operations, what we wanted to be able to do was give visibility of what was happening on those transshippers to people that were sitting in control rooms 2,000 kilometers away and could respond in a much more timely way to any disruptions or changes in circumstances around the loading of an ore carrier. So both initiatives, both the mining and the port one, I think helped get me much better understanding of how 4G could be a significant enabler for enterprise transformation. And I guess as a consequence, we've been watching very, very keenly on the developments around 5G. Great deal of interest because we've got a lot of use cases that we've identified that I can go into more detail later on in the discussion, but we feel that at this point in time, at a very high level, a lot of those would benefit from technologies such as 5G to support them.
Indeed, indeed. Well, when you write your life story and biography, I'd like to have the first copy signed by you, because even just then I was tuning into thinking, wow, what an amazing life and what an amazing career. And yes, as Australia's the 6th largest piece of dirt and almost empty, it presents a whole range of interesting, unique challenges which you're clearly facing there. Aashu, I wonder if I could bring you back in here in your role as Vice President and Client Partner for Communications at Cyient. Could you perhaps give us a brief introduction to yourself and your role at Cyient?
Certainly. So Cyient obviously is a collection of about 14,000 scientists, as our CEO calls us, and we apply technology to solve problems that matter, and that's sort of a very wide remit. And we are organized around 10 verticals. I think I earlier alluded to that. On a personal basis, I'm an engineer by training, with a background in machine learning and analytics. That was a subject of my PhD thesis. However, you could say somewhere around the 23, 24-year career, maybe around 15 years ago, I crossed over to the dark side and moved into marketing and solutions consulting. And I began to have a lot more fun. So at Cyient, my role as a global client partner for our comms and utilities BU, which is the largest BU within Cyient, about 4,200 associates. I get to go and bat on behalf of our customers. I understand and listen and think about the problem and go back and design the right solution for them. The remit is both global and it's also across CSPs and enterprises. So we obviously serve CSPs through our comms BU, but across the 10 verticals, I cross-pollinate and work closely with my colleagues in other organizations. So it's an exciting, nowhere as close as what Ray was describing. I was listening to him just like you, and I was, wow, that's a fun place to be. But what it allows me to do is to go talk to colleagues in rail, in mining, in transportation, in utilities, in automotive, and then apply technology creatively to do network transformation. So that's in a nutshell my role.
I have it on very good authority, and I certainly know from my own background with you, your career is just as broad and deep. And likewise, when you write your book, I would like the first signed copy personally handed over. Both of you have amazing pedigrees in personal, professional life, and we're very honored to have you both here. And thank you so much for making time to be available for this event. So, folks, just as a reminder, as we go through this discussion, please use the pigeonhole function to ask questions. We will also have a poll coming up after our first topic that we'd like you to participate in, and I'll give you a heads up on when that's coming through. We'd really like to see you putting your questions forward as we go through, and the team will bring them to our attention so that we can integrate them into the conversation where they fit, or if not, we will definitely attend to them at the end in a Q&A section. And for those who are on social media, again, just a reminder, you can join on Twitter. Make sure you are following the Cyient handle on Twitter. That's at CYIENT. And search for the Designing a Connected Tomorrow hashtag and click on latest and the conversation we posted there. Any questions you post there on Twitter under the hashtag, we will definitely pick up and again bring into the conversation where we can, or get to them in the Q&A section. So let's kick off on the first topic here. One of the things that we're seeing across boardrooms globally is this whole question around what 5G is and what it means for enterprise transformation. A lot of people are talking about the likes of Industry 4.0 being enabled by 5G. So I was very keen to get both our panelists to share their thoughts around what some of the key capabilities of 5G can offer, and what in particular makes it attractive for enterprise. So Aashu, I wonder if I could kick off with you to share your thoughts around this topic.
Sure, Des. It's a great place to start, and people argue that 5G is just another G, and certainly with every G we get bigger, better, faster speeds, thicker pipes, and that is, I think, purely looking at it from a consumer point of view, right? The people may have a valid argument that it's just faster and better. However, when we look at 5G from an enterprise perspective, which is the topic for today's conversation, it almost reimagines how business can get done. It's very transformative, and there are certain capabilities inside 5G that allow that to happen. 4 of these come to mind. One is density. So like you said, people talk about IoT and 5G almost synonymously with each other, right? So when we're talking about sensors, a factory floor could have tens of thousands of sensors, hundreds of thousands of sensors. So one of the things that 5G allows is increased density. So within 1 square kilometer, we can now address 1 million endpoints. Whether this is robots, sensors, shop parts, assets, any kinds. And this is a 10x improvement over the prior generation, over 4G. The second, I would say, big deal is in latency and reliability. So there is a concept called URLLC, the ultra reliable low latency communication, where we could potentially operate and have a round trip time of less than millisecond. So imagine if you were operating a crane or a heavy piece of heavy machinery from your cubicle looking outside. As you would move the joystick or any control, the machine would actually react in a sub-millisecond time. And I think this is a key feature that allows many kind of robotic process automations. The third feature certainly is about the extra speed, the enhanced mobile broadband. But I think at this time around, because we can also use millimeter wave and then the high band spectrum, we're talking about a theoretical max of 10 gigs to an endpoint. People used to do 10 base T and 100 base T when they were doing Ethernet wiring. So even if we said, forget the 10 gig, which is theoretical, but in a practical sense, if I can deliver more than 100 megs to every little sensor or every little endpoint on a shop floor or a factory floor, think of what it means. If you were building a new factory today, would you put 300, 400 miles of Ethernet cable and then put these hardwired drops, which makes your factory floor completely, I would say fixed in a place and then not easy amenable to change, right? Now that you can put 10 sensors around, your factory floor and suddenly give everything 100 meg, it's like a wired connectivity with wireless and much lower cost, much more flexibility. So I think that changes the game a little bit, because now you're getting really cable and fiber-like speeds. And then finally, there is a key architectural concept in 5G, which is that of mobile edge compute, where people talked about everything going to the cloud. This almost imagines the cloud coming closer to the enterprise, and in many cases being co-resident on the enterprise premises. There is a lot of traffic. Robots are generating terabytes of traffic on a daily basis. People are doing sensing and video cameras, quality assurance, etc. This video traffic needs to be analyzed right at the edge. So you put the compute element as close as possible to where the source of the data is. So these 4 concepts, and of course there's many more concepts that we can talk about, but to me 5G is transformative because of these 4 reasons. And now we're thinking about, okay, we should be able to change the way we do business and not just think about 5G as higher speeds and feeds. Let me pause there. And yeah.
Indeed. And in fact, you've reminded me of 2 examples in the use case models you were giving me there around just the volume and the speed and the low latency connectivity. When you're talking about the shift from copper networks to wireless networks, when they moved the Boeing 747s to a wireless architecture internally for people flying to consume media and content on their own devices, they were able to remove 1.5 tons of copper wire from the airplane in the in-seat entertainment, which you can imagine makes a huge difference to the cost efficiency of flying an airplane without having to carry 1.5 tons of copper around. And when they designed the Boeing 767 Dreamliner, they put 6,000 sensors in the wings. They didn't have the network technology in place at the time to carry the data. They just knew it would come. And they built this architecture with 6,000 IoT sensors that collected 2.5 gigs of data per flight. I worked out there were like 84,700 flights a day just in the American domestic airspace alone. That turned into be 43.5 petabytes of data per day on these airplanes once they all had sensors. Now, back when they released the airplane, the network technology wasn't there to move that data, but it is now. And the networks we're talking about, the technologies you've just alluded to there, are making this possible. And I guess this is where it's really important to talk about how we design these networks of tomorrow, but with today's context. Ray, I wonder if I could bring you back in here. Aashu's covered a lot of the technical aspects. I wonder if you could maybe talk about some of the differentiation and the capabilities that 5G might bring, and in particular ways it might offer opportunities for you to expand on your current networks and infrastructure.
Yeah, look, sure, Des. It's an interesting area. I feel like a lot of stuff that Aashu said, I'm only going to reinforce. one of the exciting things I think with 5G is that it just opens up a whole new set of use cases that we haven't been able to contemplate with previous Gs, or even just wireless comms, more traditional wireless comms and wired comms. The increased bandwidth capacity. Aashu mentioned high definition video is something that we would love to be able to pursue, right? It gives us the ability for remote visual monitoring and the flexibility to deploy devices without having to worry about cables, pulling cables, things like that, particularly when you're operating in very remote environments. That's not an easy task at the best of times. Let alone some of the contextual stuff that we have to deal with. The latency aspect of it, the lower levels of latency, but with the ability to move across to real-time control. So we've done, even with the mesh networks that we currently have in place, wireless mesh networks, we're doing monitoring, but the performance of the network isn't there yet that we're confident that we could go towards sort of real-time control. Because of the speed at which some of the decision making needs to be performed at. So latency, the ability to deploy workloads at the edge means that we're now in a position to start exploring scenarios where we are collecting large volumes of data and based on some almost real-time analytics is make a decision that then can be transformed, if you like, into a command back to an asset to respond appropriately, either to protect the asset or to ensure that there's a stability of supply to our customers in terms of electricity. Aashu mentioned density. That's a huge thing for us. We've got two interesting scenarios. We operate in regional towns, and within those towns, what we're seeing is this drive towards customer, what we call DR. Rooftop solar is a great example of it, batteries and whatnot. Left to evolve on its own, this actually causes this enormous problem in the stability of the electricity network. So what we're currently doing is exploring technical solutions as to how we manage and orchestrate the flow of power across our network, from customer generated power through to utility generated power. And what that actually means is we need the ability to control assets that might be belonging to the customer. So these aren't assets that we deploy or sensors. It's the ability to connect to those assets. It might be an inverter, could be a battery that's in the customer premise. And we want to be able to monitor weather conditions in real time and then respond accordingly and interpret, right, there's a cloud event coming. That means we're going to lose a lot of renewable solar production on the network. So we need to then spin up our generation assets by way of an example. I won't go on, I could go on forever on a topic like that. But that's the world we're sort of moving into. So the ability for 5G to play a part in helping us control and orchestrate the flow of power through the energy supply system is fast upon us. Some would say it's already there and we need to already have solutions in place.
It's an exciting time.
It is. Oh, it's enormously exciting. And security and control. I think one of the things, I won't pretend to be an expert in this area, but what my guys are telling me is the ability for security and control to, in a 5G world, through network slicing. An interesting evolution in our business model is to leverage our IoT platforms so that we can actually federate the use of IoT services to third parties out in the regions that don't necessarily have the wherewithal to make that investment themselves. We see that a couple of benefits. One, it adds value to our revenue, but 2, it adds value to the remote communities that we service, in that we're making the foundational investment, which they can then leverage on top of that. You know, we seeing things in the 5G space that give us some comfort, at least at this early stage, that some of that thinking that we have will be well supported through 5G architectures and 5G networks.
Fantastic. No, I was just visualizing the idea of traffic management of electrons flowing through your network when someone connects some other device, and it brings a whole new meaning to network management. And I'm sure we could have a whole new show on just the challenges you have around asset management and vegetation management. But you did highlight something that I just wanted to touch on briefly before I move on, because we have a poll coming up, folks. One thing that struck me was you mentioned the use of cameras in the environment, and you know, we all walk around with a phone in our pockets these days that invariably have 4K cameras, and we don't think anything of taking a picture in 4K or streaming 4K video for consumer level stuff. But one of the things I'm seeing, particularly in your world, Ray, with likes of the combination between asset and vegetation management through to physical and logical and virtual security, the idea of one big 4K camera pointing at a large space with a 5G network streaming this data and geofencing locations. You know, should this piece of equipment be there? Should that person be there? Is someone crossing a boundary from a safety point of view, or whatever the case may be? I think we could do a whole show on that alone, but we won't go down that rabbit hole. Very exciting times. Well, I'm looking forward to seeing how you do deploy those. I think one thing you also just reminded me of is that you know, your core business around the utilities and power space. I think it's ever more important as this whole conversation today is about finding the right partner of choice to help you build those networks, as it is for other enterprises. Folks, let's just pause for 30 seconds here. We're going to pop up a poll for you. We'd like you to take 30 seconds now to just give us a little bit of input from you. So before we move on to topic 2. So let's take 30 seconds now just briefly for an attendee poll for our audience. If I could get everyone to use the poll feature to share your views by voting now. The question is, which industries do you see adopting private networks faster? If you could maybe just take 2 seconds to submit your vote on that. As you can see there, the options are mining, manufacturing, utilities, automotive, and medical and healthcare. We'd really value your input there. So just take a moment now, if you don't mind, to vote one of those and click submit, and we'll review that data as we go. And while people are doing that, I'm just going to briefly prepare here for our next topic. So we're about to talk about a second topic here. Next generation networks, as we mentioned before, offer a broad range of different architectures that enterprises can consider when implementing private networks, and we'll be diving into it in a moment. So I'll give you another 10 or 15 seconds for the poll. If you haven't already done so, please click on something and click submit. We'd really appreciate your input. And the data will be available to all of you participating on the platform. So not only will you see your votes and views, but you'll be able to see what the rest of the audience is thinking and saying as they join the conversation. And again, bring your questions through the whole hour. Okay, thank you so much for taking time there. So just briefly looking at that, when we think of the data here, as you can see on the screen, essentially 20% of people and 19% thought mining was going to be interesting that would adopt private networks faster. 24% in manufacturing, 33% in utilities, probably a good fit for today's expert panels. 10% in automotive, which I'm surprised. I think automotive is sort of the silent little power engine that's going to take it. 14% in medical and healthcare. Well, there's no secret that utilities are definitely going to be able to leverage this technology, and let's dive into that in a little more detail. So as our second topic, just let me summarize that. So as I mentioned, next generation networks are going to offer a broad range of different architectures that enterprises consider when they look to implement private networks, with a plethora of design patterns that these enterprises can consider in this space. There are a couple of examples: completely air-gapped private networks, private locally hubbed networks with minimal external connectivity for the likes of, say, mobile edge compute or mobile edge networking, or the likes of, say, densified versions of the carrier service provider network architectures for, say, industrial use cases and so on. Ray, I wonder if I could bring you back in here to share your thoughts around the space. Could you maybe give us a little insight into how you see this might play out in your world there at Horizon Power?
Well, a little bit like looking into the looking glass.
Indeed.
Yes,
That's
yeah.
why we have
Look,
experts like you here. You
I've got to be
tend to have a better view of
transparent.
the world than the
Put
rest of
my
us.
hands up and say I'm not an architect. Don't feel particularly well qualified to comment on the various options for enterprises to consider. But look, I think what's really important for us, we're going to stay true to a bit of a process here, right, is to make sure that we have a really good understanding of what our requirements are. So what are the various use cases that we want to try to address, okay, and use those as a basis for exploring our options with respect to what is the most appropriate, what are our architectural options and what are the pros and cons associated with each, and which one makes the most sense given what we're aiming to achieve. Look, in addition, as part of the process, I think I expect will involve also exploring some of the following questions. For us, we'll look at it and ask ourselves the question, will most of our traffic stay within our walls, or will it need to head out to the internet? And what applications do we have that would benefit most from compute capabilities closer to the edge? All right, so I think those sort of things will come into play to help inform what the most appropriate architecture is, as well as to pick up a point that Aashu made earlier, what device types, capabilities and density will be in play as well, right? Because I think you've got a number of options. There are some architectural options or configurations within 5G that sort of lower your capacity, if you like, your bandwidth, but extend your range. And the flip side of that is higher density, shorter ranges, but much more capacity and bandwidth and latency. So it's an important question to explore, and I think we'll get there in due course. Literally give it months for us, and if you don't give it sufficient thought, well then I think you could end up wasting a lot of time and money. So another key area for us to also consider is a transition plan, because it's not as if we're coming off nothing, right? We already have an existing wireless mesh networks in our region. So these we have smart meters everywhere. These smart meters converge to create a wireless mesh network. They connect back to an access point which has a 4G backhaul. And that's great. It serves a terrific purpose. It's been in place now for about 5 years, but we are getting to that point where we see the need, the requirement for other business cases, use cases, which the mesh network won't support. So for us, one of the things we've also got to consider is how do we transition from where we are, where we've got something, to where we want to be. So I'd be interested, if it's okay with you, Des, to listen to Aashu's perspective on this. I've got my my pad and my pen handy, ready to take notes. In fact.
Indeed, and in fact, I've had the pleasure of having a number of conversations around this topic with Aashu in private, and I literally did exactly that. I took pages of notes and reviewed them later. So I'm 100% with you on all of those, Ray. And Aashu, let me bring you back in here. And there's a question around the impact of cloud in these design patterns, which I might also bring back to you in a minute, Aashu. But first, I wonder if you could share your thoughts on some of the suitable architectures for deploying private networks in the context of what we're just talking about.
So first, let me say that, whatever Ray was talking about from a sequence of events perspective, that absolutely makes sense. And this is how we would go about thinking about it, because you have to look at what is the use case or a set of use cases that is actually paying for the private network, right? And as we said, we have a digital team that actually goes and implements that particular use case, whether it's migration from a Wi-Fi mesh network to an LTE or 5G network. And are we talking about worker safety? Are we talking about precision drilling, autonomous haulage? Are we talking about smart meters? Depending on the industry, the use cases vary. But since the question is about architectural options, I would say the nuances are many, but they boil down into roughly 3 buckets. And first bucket is what you would call sort of an air gap network. There are manufacturers building gear for defense, the defense contractors, or there's customers that are really highly sensitive to security. They don't even want their surveillance data, any kind of data, leaving the premises, and they prefer a completely private network where this doesn't talk to the rest of the world. Everything that is produced is consumed locally. So robots talking to sensors, talking to device control, and you may want a version of your network completely isolated that way. And the entire network sits in a closet with small cells, radiating around the sites. So that is, I would say, is a standalone network. And let me talk about the third option, and then we'll come to the hybrid. And the third option is almost a dense version, what you would call, DAS, a distributed antenna system, where you almost pull a fiber from a CSP, the local CSP, and then you densify the network around a site. So, a manufacturing site could be remote. Certainly, a consumer-grade network that a Telstra or an AT&T or a Verizon provide. These are designed with no SLAs, and these are designed to cover a certain number of millions of users across a very wide geography. So suddenly, if you put 40,000 endpoints in a tiny little area, you can guarantee that none of them is going to get more than half a bar, right? You suddenly, it's not designed for it. So we almost take a slice of the carrier network, densify the local radio to make sure it provides enough coverage, and then agree with some sort of an SLA with the carrier. So the carrier is almost giving you a slice, almost like a T1 line, which guarantees a certain, the old analogy of a T1 line. And this is what we call network slicing. And then in the middle, there is a hybrid where the network is private. The signaling hairpins from the CSP, so that could signal from remote, but the media is all kept local. And that's where the mobile edge compute part comes in. So you could be doing video inferencing at the edge. So that's a hybrid of the two. In general, though, I would like to say this, that from Cyient's perspective, we think of the customer needs first. We don't have a vested interest in pushing one architecture over the other. CSPs may have their preferences, and other managed services providers may have their preferences who are building products. In our case, we think about the customer's need first. We start with the journey that Ray has outlined so eloquently. So, and I'll leave it there. So.
Absolutely. We've got a question, Aashu, if I could just stay with you for a moment. I hope you don't mind. There's a question related to the impact of the cloud-focused design patterns and how that might change network design, network deployment, and so forth, and in the context of 5G, but in general. I wonder if you could just very briefly, in 60 seconds, give us your thoughts on how that might either benefit or impact some of the focus that enterprises need to be considering when they think about the deployment of some of these new next-gen networks, given that they are very DevOps and software-focused.
Yeah, so there is two ways in which the cloud comes in. One is in where the compute's happening, and does the traffic need to leave? There have been cases that I have worked with other partners and customers who are. I'll give you this one example of doctors doing, for example, colonoscopies and looking for polyps, cancerous polyps. So the data they're generating is local. That's actually happening in the OT. But this data needs to be compared with a bank of 100,000 potential polyp images, because you're trying to do high-res video imagery, and you're trying to compare it with something that is known or has using machine learning techniques, you've classified things as cancerous or not cancerous, right? Now that data clearly sits in the cloud and is not the property of one known hospital. It's a collaborative effort that has been built over the years. So you want to compare locally produced video with something that sits in the cloud. So to the extent that we can get an instance or a copy of that cloud data as close as possible to the hospital and hairpin the traffic locally. So we're talking about a distributed cloud, and I know that Amazon's working on concepts like wavelength. They have concepts like snow cone and snowball, where they're gradually pushing the cloud closer and closer to the edge. And then other cloud vendors are doing just the same. And there is this extreme example where the enterprise will say, my data, I can have completely private instance right within my premise. So So cloud plays in that sense. And the second aspect where cloud plays is in the deployment architectures. Do you want any gear sitting on your premises, or is there a fat enough pipe where if this was sitting 50 miles off and then being run in a completely managed environment? So it's a customer preference on, does their team need to feel like they have control and strict ownership, and it's in a locked and keyed cabinet, versus it can sit off premises as long as virtually it is theirs. It's a dedicated hardware. It's just for them, but it's in a data center somewhere close by. So I think those are a couple of nuances that we can go to, but certainly when we're trying to match locally produced data with globally produced intelligence, that's, I think, where the question is, how close or how far do you want to be from the cloud? So I'll leave it at that.
Appreciate it. Yeah, thank you very much. Yeah, I think that, again, this reiterates the whole point of today's conversation, that it is so important to find a partner of choice like Cyient to help with some of those conversations for that very reason. And often we're seeing some of the fundamental fabric, such as the operational support systems, or OSS, or business support systems, or BSS as it's called in the telco world, where OSS and BSS functions are containerized, they're running in Docker, they're running in Kubernetes, they're in cloud models, either on-premise, hybrid, or in public and private clouds. And this is such a different design model from what we used to have, where we got routers and switches and servers and cables in the ground, as Ray was mentioning before, out in racks in the field. And this is not something you can get wrong. It has to be done right the first time. I wonder if we could now jump to our third topic. We're getting through the hour here. I wonder if we could, in a little more briefly, concise fashion, and this one to keep track on our time. The third topic I wanted to touch on was when we see organizations looking to implement next generation networks and drive business operations transformation in particular, one of the key drivers that they're often looking for. Really keen to get some insights around what some of the use cases and potential ROI opportunities are that they can look for, especially in the likes of utilities, such as rail and port and so forth, and obviously energy market segments with Ray here today. Aashu, I wonder if I could maybe start with you again, just around the space, particularly some of the use cases and ROI opportunities, or return on investment opportunities that enterprises can look for, where next generation networks can in fact drive business operations transformation in your view.
Yeah, and then this is a sort of the great topic to tie it all together, right? What's the use case? And certainly they vary by industry. So I can start maybe with a couple, in the mining space, and I'll clearly defer to Ray when it comes to utilities. He's the expert here. But if you look at mining, for example, I mean, the first big problem is the remoteness of the site, and these sites are big. Some of these sites are 50 kilometers by 70 kilometers. That's like 2 times the city of Boston, where I live. And its appropriate coverage is very hard to do with Wi-Fi, trying to cover that large an area. So certainly macro cellular network or a mini cellular network there makes a lot of sense. So that the coverage alone becomes a good use case. And the use case then on top of it could be, autonomous haulage, right? So you have these trucks running around, well-defined paths, precision drilling, and then sensing what the drill is seeing at the front end, which is being compared with data, and you're doing inferencing at the edge. That's another key area for mining is worker safety. So you have every helmet has a sensor or an asset tag, so you know where every human being is, and these large machines, which probably cannot see very well around them, have a geofenced area that is marked, right? So anytime a human gets into the boundary of a large crane at a port, or a big piece of heavy machinery, the machine will come to a stop. So you're trying to minimize any sort of personal injury. On the utility side, since Ray's here, I'll just talk about the 2 use cases that I've seen from the US-based utilities, so New York Power and a couple of California utilities. One key use case that they talk about is drone-based inspection. So they completely are thinking about building a drone network and then using that over a large geography to inspect power lines and their transmission gear and power generation gear. And the other thing that they're intent on doing is sensorizing the entire network. So they want to put, how do you bring legacy dumb devices into the new age, right? So you put sensors, advanced sensors. That's an area science specializes in, and we bring them into the IoT era. So once you have this network sensorized, anytime there is a storm, fire, any kind of thing, anything goes down, the utility can isolate within seconds and in future within milliseconds where exactly is the source of the problem, so you can deploy your troops there. So I think that's and then for manufacturing, the one use case we talked about earlier was why would you build a wired factory anymore? So that clearly, but quality assurance is a big use case. So robots constantly sensing and picking out products from the assembly line which have some sort of defect, and now you can do very good video-based analysis. So that's a key use case for manufacturing. I'll pause here and pass it on to Ray to talk about some more of the utility use cases because he may have a better insight.
Absolutely. And Ray, sorry to make it seem like I'm rushing you, but I wonder if I could just get you to give us one example use case that you've seen where this might suit utilities organizations such as yours or related industries.
Yeah, look, I'll give you one quick one, Des, which is quite important to us, which is high voltage line sensors, fault monitoring. Okay, so we've got HV networks that in some of our regions go for hundreds of kilometers. And every so often, unfortunately, they develop faults. And what typically tends to happen at the moment is that we'll send people out to do a visual inspection to identify where that fault is. Usually, it's easy to identify the fault, but it means driving potentially quite a significant distance to work out where that fault has occurred. So with IoT sensors deployed to the network, we potentially could isolate exactly where that fault has occurred, and we'll be able to direct work crews straight to that location first up, without wasting all the unnecessary time it takes to drive along the lines to identify where those faults have arisen. So that's one in particular. We've got a myriad. In fact, we've got a document that probably extends 3 or 4 pages of things like this. So there's a world of opportunity on the table for us in our space.
No doubt, and I hope to have you back on another conversation soon to delve into those. Well, Ray, Aashu, thank you so much for that panel discussion and addressing some of these key topics there. These are the topics we've seen across the world in boardrooms that are appearing regularly on agendas, boardrooms on a monthly and quarterly basis that organizations at enterprise level are very concerned about and how they address those. You've given us some great insights, some great anecdotes, and really appreciate that. As we wrap up the hour, we've got a few minutes left. I'd like to bring in some of the questions that we've now had from our attendees, and thank you everyone for holding on now. We really appreciate it. Thank you again for your input through the poll. So in the last few minutes, if I could maybe just now bring in a couple of questions from our audience, and forgive me if I paraphrase as we run towards the end of the hour there. Ray, if I can stay with you, I wonder again, just very, very briefly, we've heard a lot about the technology benefits that private networks can offer. I wonder if you could share just, there's a question here, someone asking if you can share an example of business benefits that private networks can bring as they offer more cost-effective connectivity and offer opportunity to reduce costs, I guess, and results to enterprise.
Look, I think one of the biggest business benefits that's available to us, obviously every one of our use cases has enormous business benefit, but the business benefit to me of having a private network of some shape or form is the flexibility that affords you. Okay, right now, as it currently stands, we're very dependent upon a telecommunications provider. I'll leave them as nameless, but it's a huge inhibitor in terms of our ability to move in a very agile, quick, responsive way. Okay, it takes an inordinate amount of time, and quite often we're at their mercy around their schedules for doing this, that, and the other. Right. So I think one of the biggest benefits I saw back in my previous career at a mining company was that once we stood up our own private LTE networks, we could move as quickly, as slowly as we wanted to, and focus exactly on what we needed to do. Right. We were able to do very fast use cases to test hypothesis, gather the necessary data, and use that data then to verify and validate whether it was worth scaling out. and we had complete control. So that was, there's an enormous value in just being able to take that particular approach to things. Great deal of freedom, and what it also meant was that we were able to generate a return on investment a lot faster to the business.
Fantastic. Aashu, I wonder if we can wrap up the hour and close with you and a final question that's coming from the audience. There's a comment here that we've talked a great deal around the whole challenge of designing and building private networks and deploying. One of the questions that's come in, I'm going to paraphrase a couple of them here, is I wonder, Aashu, if you could just maybe touch on some of the challenges you're seeing around managing some of these networks as they're deployed, and some of the managed services that are required people should be thinking about.
So I'll say the following. There are certain enterprises that are large enough in scale that possibly have the wherewithal to operate a comms network by themselves. But this is not a simple task, right? And in some cases, enterprises feel more comfortable doing what they do best and leaving the comms network to some sort of a managed services provider. So Cyient is really investing heavily into building a multi-tenant NOC where we can bring that economy of scale to even smaller size customers, and we can sort of operate. And the other thing we can do is the financial engineering, where certain customers have, a bunch of capex available and they want to work in the classic capex opex model, whereas other customers simply want to put it into an opex, multi-year opex plan. We're simply getting network as a service built for them, but then being operated. So I think those are some of the enterprise challenges when they begin to think about, okay, how do I get started? And I believe the first thing starts with a set of use cases, considerations like Ray had highlighted, and then think about how is it going to get paid for, and then what's the ROI, and what's the operating model. So I'll just leave it at that for now.
Fantastic. Well, gentlemen, thank you so much again for your time. And I want to really thank our attendees as well for registering and joining us for the day and sticking for the whole hour. It's been an amazing conversation. A huge thank you to yourself, Ray Achemedei, in your role as General Manager of Technology and Digital Transformation from Horizon Power. We really appreciate your time, Ray. It's been great to have you here. And Aashu Virmani, Vice President and Client Partner Communications at Cyient. Aashu, again, thank you so much for your time. It's been great to have you here. And folks, thanks for joining us for the CXOCyience second event live stream. We would really appreciate you continuing the conversation with us. So please do make sure you visit the Cyient website at cyient.com. That's CYIENT.com. And make sure you follow Cyient on LinkedIn and Twitter for the regular updates they provide and the information they share on social media and digital platforms. And as I said, join that conversation, post any other questions you have, reach out to the team. In the meantime, thank you all for your time. Thank you, Ray. Thank you, Aashu. And a huge congratulations to the team at Cyient behind the scenes who make this possible. As I said, this is the second series. We'll look forward to seeing you in the next one. My name is Des Blanchfield. It's been an absolute privilege and an honor to host and moderate this panel today, and we'll look forward to seeing you again soon. Have a great day, great evening, great morning, wherever you are, and stay safe. Thank you.